Why do we need the semantic web? Well, to answer this question, we first need to ask, why do we need semantics in the first place? It is semantics that gives raw data meaning and a way to interpret it. Without an understanding of semantics, we would not be capable to understand given information and make conclusions about it or infer new information from it. Or can you explain to me what the ones and zeros on the screen mean? In our mind, every word or thing has a specific meaning that is expressed through multiple relations to other things. For instance, these data objects, like knowledge or context, are just strings without meaning. In the end, the relations give meaning to things. That's how semantics work. It is not only important in computer science, but also in our everyday lives. If you have a set of data that needs to be processed, the computer would never be capable of understanding this data by itself. Instead, you develop an algorithm that defines exactly step by step the logic of the data and what the computer has to do with them. Without this logic, the data would remain unprocessed and the computer would never know what to do with the data. Semantic web technologies allow for connecting the logic with the data in one unified model, which is often called an ontology. The computer uses a special software called reasoning engine or reasoner, which allows for interpreting the logic and underlying data of the ontology. This method has one huge benefit: the exchange of knowledge constructs between different software applications. Through this exchange, it is possible that various data models with corresponding logic could be developed and would be understood by any application that uses a reasoner. Furthermore, links between different ontologies could be created and new contextual information could be inferred. Since the machine is interpreting information by itself without knowing the logic or any algorithms before receiving corresponding data, ontologies or knowledge graphs are usually classified as a category of artificial intelligence, or in short, AI. But unlike AI tools most people know, like ChatGPT or Claude, ontologies work not based on correlation and stochastics, but are based on logic and causality. Therefore, ontologies are categorized as symbolic AI. Knowledge can refer to various domains and subjects, such as medicine, jurisprudence, buildings and construction or news. Often, this knowledge is interconnected. For instance, if some knowledge components occur in multiple domains. For example, a hospital can occur in the building domain as well as in medicine or in the news. These common components could be interconnected with each other and create a web of knowledge domains. Perhaps you can guess what the result would be: the semantic web. By using standards established in the semantic web, the computer is not only capable of interpreting the meaning of given knowledge and correlated information, but also of understanding connections to other related topics and knowledge domains. It's like if the computer gets a module for understanding medicine, engineering, or video game history. We humans work in a similar way, but instead of importing files, we read a book or visit a lecture. However, you will not understand the topic until you can draw conclusions on your own, based on thematically related information. Computers that utilize semantic web function the same. This leads to great potential, since when knowledge about medicine or engineering is understood by the computer, new information could be inferred, based on given facts. This would even be possible across various disciplines that have some things in common. Therefore, Semantic Web touches the field of AI the same as other machine learning technologies do. In this oversimplified example, we can infer that Alfred is a diabetes patient if he has high blood sugar for a duration of 6 weeks. The use cases of semantic web technologies are enormous. For instance, with medicine knowledge, the computer can get information about patients' symptoms and conclude which diseases potentially affect him. Another great example is the dynamic semantic publishing system of BBC. When a news article or a piece of content is created, it is semantically tagged with relevant entities like people, places, and organizations. The dynamic semantic publishing system then automatically aggregates related content from various BBC sources, ensuring that users are provided with a richer and more comprehensive set of resources on a given topic. This approach allows for more efficient content reuse, enhanced search capabilities, and improved content recommendations. Furthermore, the knowledge of encyclopedias like Wikipedia is structured in the semantic web of DBpedia. By structuring Wikipedia's information semantically, DBpedia allows developers and researchers to build sophisticated applications that can understand and leverage the rich knowledge present in Wikipedia in a machine-readable format. For instance, one could query DBpedia to find all the album titles of a favorite band in chronological order. As you can see, the potential of the semantic web is promising, and in my opinion, the semantic web is a key technology of AI to make machines knowledgeable and more accurate. In the next lessons, you will learn more about various use cases in the semantic web technologies that are covered by them. If you want to learn more about ontologies, linked data, and the semantic web in general, I can highly recommend my Udemy course. There you will not only learn all the basics about RDF, but also about the query language SPARQL, automated inference of new information using reasoning, and developing your own ontology-based apps. You can find the link to the course in the video description.